For our group project, we decided to compare and contrast social media versus text messaging. This includes 4 and 5G networks, along with a variety of current social media platforms such as Twitter, Instagram, and Facebook. To start us off on some of the comparisons and contrasts that we'll be making in this presentation, we begin with networks, an exploration of the transmissions, the protocols and the features of each respected system, the hardware that each system uses, specifically the devices that are utilized, the software that each of the systems are run on, and the specific features of those applications, and finally the interfaces. So each system connects to the users and is available to the users. To give a brief history of both of these respected systems, we start off with text messaging. It was created in 1992 by Neil Papworth. It started off actually without keyboards, which meant you had to manually input each character. But by 2000, the average person in the US was sending 35 text messages a month. This only continued to rise, and by 2007, it even surpassed the number of calls that were made every month. And then one of the big milestones in 2011 was iMessaging, which came out with a variety of new features that could be utilized by the users. Today, you probably recognize iMessaging for the ability to emphasize, like, or dislike messages, and then the variety of emojis or GIFs that you can send across text messaging. Social media, it was first created in 1997, the first modern platform. 6 Degrees, I'm sure none of you have ever heard of it. Blogging became popular in 1999, which then ignited the social media culture, creating a need and want for major platforms. This in turn created things like MySpace, LinkedIn, and Flickr. And then some of our modern day platforms such as Facebook and Twitter came in 2006.
Okay, so getting into networks and their functionalities, our group took a look at the more modern day examples of mobile networks, those being 4G and 5G. So the G in 4G and 5G stands for generation. So the first generation came about in the mid-1980s and rapidly grew over the next 30 plus years with the advancement of cell phone technology. So today, we have a more widely used 4G LTE, which stands for fourth generation long-term evolution, that was first introduced around 2009. And the big thing about this network was that it made high-quality video streaming more of a reality and offered fast mobile web access, which at the time was up to 1 gigabit per second. However, unlike its predecessors in 2G and 3G, when 2G and 3G came around, you could just swap out a SIM card to get the new network connection. But when 4G came about, mobile devices had to be specifically designed to support that 4G network. But if you fast forward to today, you start to see 5G networks popping up. Now, everybody thinks 5G networks are this brand new thing that just came about. However, this is not entirely true. It's not an entirely new network. It's been in the works for quite a few years, and it's said to be 100 times faster than 4G because of its super high frequency airwaves. And it also contains more capacity, which allows a better connection with many more devices. It's almost like having a new and improved freeway with more lanes for more cars to drive on. Now, when it comes to breaking down information sent across the internet or to another person, whether you're using social media or text messaging, 4G and 5G are able to send 8-byte packets of information. But when it comes to things like speed, like if you're texting someone or posting something for a bunch of your followers to see on social media, 5G essentially wins that race based off the simple fact that it's cloud-based. So it's not like SMS or MMS or 4G networks that are a little bit slower and have higher failure rates. And they also have a limit on the amount of characters you can send. And usually when we talk about networks, we think of TCP or the IP model or the OSI model, which have 4 and 7 layers respectively. But that's only if you're trying to use social media on your laptop or your computer. When we're talking about texting versus social media, we're usually talking about users that are using this on their handheld device, like their smartphone. And those use what's called Code Division Multiple Access, or CDMA. And some networks use Global System for Mobiles, or GSM, which are multi-layered networks used to transmit information. However, with the arrival of 5G, a lot of phone companies are starting to phase out this network and implement 5G into their devices.
When considering the hardware components of social media versus texting, social media uses cloud computing, so it only uses the internet through fiber optic cables in the cloud. Social media and text messages are stored on a massive amount of servers, so companies like Facebook have nearly 30,000 servers. So for the cloud computing, data center is accessible through the internet. Components include switches, routers, firewalls, storage arrays, backup devices, and servers. Within any single data center, data may be stored across many disks in a single storage array. This eliminates the capital expense of buying hardware and software and setting up and running on-site data centers. So not only does it save time, but it saves money. So for the fiber optic cables going into the hardware, they're like buses for the internet. These fiber optic cables carry communication signals using pulses of light generated by small lasers or light-emitting diodes. Radio towers, for going into the hardware components of that, so the electricity flows into the transmitter antenna and makes the electrons vibrate up and down, which produces radio waves. These waves then travel through the air and travel to a receiver antenna. And when it arrives, it makes electrons vibrate inside the receiver antenna and produces a current that recreates the original signal. And that's how connection from your phone works to another phone. So going into the hardware components of 4G versus 5G, so the 5G frequencies allow for large bandwidths so everyone can stay connected in crowded places. 4G base stations only have 12 antennas to transmit outputs, while 5G base stations can support up to 100 antennas. This causes a difference in latency. So the hardware of the internet, the internet is connected through a router, which consists of major components such as CPU, ROM, RAM, NVRAM, flash memory, RX boot image, interfaces, buses, power supply, and the configuration register. Going into the hardware of smartphones, this includes RAM, one of the most critical components of a smartphone. Without this, basic tasks like accessing files would take forever. Other components include internal storage, ROM, user removable storage, and display.
Hi, I'll be talking about software interface components. A telecommunication system includes a transmitter to accept information and convert it into a signal, a transmission medium to carry the signal to a receiver to receive the signal and convert it back into usable information. This applies to all types of communication system. Here I'll be talking about SMS versus social media. So SMS enables a network administrator to create an inventory of all the hardware and software on the network and to store it in SMS database. Wherein social media communications are sent out by one company and broadcast to many users on their platform, where SMS communications are sent by one company directly to one consumer in a personal or private space. As you see on the slide, the examples for SMS are T-Mobile, AT&T, Verizon, as they provide services to private spaces. And where in social media, top three I have posted are Facebook, Twitter, Instagram. They have communication media for their user through social media services. Nextly, I'll be talking about interface functionality between iMessage and Twitter, and I'll be talking about the software and the differences of their interface. Well, for Apple iMessage system, it can be signed up without wireless plan, accessible to any Apple devices, and also instant messaging service supported on iOS 5 and OS X. It also uses push notification service that enables third-party applications developers to send push notification to iOS users. It generates connection to a unique code and act as an identifier of the routes that send messages to the specific devices. Nextly, I'll be talking about Twitter interface functionality. Twitter places great reliances on open source software. Web interface uses Ruby on Rails framework, which adopt a dual panel layout with the navigator bar along with the top of scene and increases focus on the inline embedding of multimedia content. Tweeterbot is a computer program that automatically posts on Twitter. They are programmed to tweet, retweet, and follow other accounts. Therefore, it's capable of influencing public opinion about culture, product, and political agenda by automatically generating mass amount of tweets through emitting human communication. Tweeterbot also a performance booster for about 200 to 300 requests per second for per host, and also around 10,000 to 20,000 requests per second for per host. That's all, and I'll be ending my entire interface functionality.
Let's talk about some miscellaneous comparisons. So, for privacy, who can access your data? With texts, it's you, the receiver, and your individual carriers. With social media, anyone can see what you put out depending on your privacy settings. What happens to the data that you share? Text messages are stored on phones, so your phone and the receiving phone would each have a copy. Your carrier, however, may save the information on their servers for 3 months tops. This can be a little bit variable. Some carriers will hold on to text messages for a little less or a lot less. Social media, on the other hand, will save the information on their servers for as long as you have an active account usually, although this can also be pretty variable. MySpace is a great example of losing all of your data because all of the media hosted in their servers prior to 2016 was deleted in 2016, most likely because they didn't feel like migrating the data over to a new server. Let's talk about software and data. So for social media, you don't have to use a specific client in order to access the server. Social media's client is always updating itself from the server if you choose to download the application onto your cell phone. But you can also access it from a variety of clients and devices. And the server and client will talk to each other to update whatever the client you're using is. So the device that you're using to view the social media on doesn't have to save so much information. On the other hand, texting is dependent on cell towers. So the speed at which you may receive a text message depends on which carrier owns the tower that you're close to, what agreements there are for the carriers that use that tower, if you're out of network or if your cell phone's off. If your cell phone's off and somebody sends you a text, what'll happen is their phone will send the text message to their cell phone carrier's server, and the cell phone carrier server will send it to the receiver server, and your receiver carrier and the sender carrier will both hold on to that information for anywhere between 30 days and 3 months. And once your phone comes back into network or it turns back on again, the text message will be sent on a low importance frequency to your cell phone, which is why sometimes it can take anywhere between minutes and days for a text message to get to your cell phone. Your phone also needs to have dedicated software to receive and translate and send SMS and MMS. Now, the reason for this is because SMS and MMS are a different kind of packet from the TCP packets that we use on the internet. Social media and texting are very similar in that the hardware that enables both to work are often either similar or the same these days, and the introduction of each made big splashes in how we exchange information and what we do with that information. The concept behind both are the same, using packets of data to share information over a series of connections, but the differences lie in who keeps the data, what kind of packets are used to send the data, and privacy. As time passes, the concepts between social media and texting will only continue to blur, as it already does with messaging apps. Some network providers don't use SMS anymore and rely on email-like alternatives. SMS and MMS are falling out of favor due to how they're handled over a network and how unreliable they can be. Our current technology is moving towards being more internet-focused as access to it becomes more widely available, and cell phones are moving to keep up with that change.